Except over here. Now let's analyze the entire results for two different metals. Suppose there are two metals A and B. Angles are theta A, theta B. These are the intercepts. So from the graph we can analyze that both of angle are equal and equal to 45 degree. Then as evident from the graph, work function for B is greater than that of A, which means threshold frequency of B is greater than that of A, which again explains that threshold wavelength for B is less than that of A. Now is the question that graph between kmax and frequency of photon. So kmax is E minus phi naught, and we can say that E is equal to h into nu. So that is again going to be a straight line, just like this. And here tan theta is equal to h, which is constant for all. Now let's compare the graphs for two different metals. Suppose there are two metals A and B, angles are theta A, theta B, and the corresponding intercepts are phi naught A, phi naught B over here. So from the graph we can say that phi naught B is greater than phi naught A, as it is evident from the graph. Phi naught B is more than that of A. So larger the threshold frequency, larger will be the work function, and smaller the wavelength. So that is going to be the pattern between A and B itself. So we can say that graph between maximum kinetic energy and frequency is a straight line having its slope equal to Planck's constant, and intercept is equal to minus of phi naught, where phi naught is the work function of the metal. So for different graphs we can say graphs will be parallel, but different intercepts will be there. Now there is another question on three different metals A, B and C. These are the frequencies, and the unit here is 10 to the power 15 hertz. Then first of all we need to find phi A, phi B and phi C. Theta A, theta B and theta C, the angles. So angles are equal for all, so that will be 1. Then we need to find relation between the threshold frequencies. So obviously this point corresponds to the threshold frequency. So for C it is greatest, then B, then A, we can say that. Then is the work function. So obviously C is gonna have maximum work function, then B, then A. Wavelength is in the inverse order. So wavelength, threshold wavelength for A will be greatest, then that of B, then that of C. That we can calculate using these. Next is graph between kmax and wavelength of photons. So we know that kmax is E minus phi naught. E is hc by lambda. So the graph here will be like this.